Exam number 2 prep. This exam follows the same steps as exam number 1 and will be on Canvas under the quizzes section. Use Respondus Lockdown browser with your front-facing camera on. You may use personal notes and a physical textbook, but headphones and ebooks are not allowed. The exam has 35 questions, 30 multiple choice, and 5 short answer. The exam opens on Wednesday, July 2nd at 12 p.m. PST, and it closes on Thursday, July 3rd at 12 p.m. PST. After all, just prepare the same way you did for exam number 1. Chapter 6 covers key concepts about money, inflation, and interest rates. The quantity of money equation, M times V equals P times Y, links money supply and velocity to prices and output. In growth rates, assuming constant velocity, we have pi equals percentage change in M minus percentage change in Y. So faster money growth leads to higher inflation. The Fisher equation, I equals R plus pi, shows that nominal interest rate equals real interest rate plus inflation rate. Money demand depends on interest rate and income. M over P equals liquidity, a function of I and Y. In equilibrium, M over P equals liquidity, a function of R plus E pi and Y. That means if expected inflation rises, nominal interest rate rises and real money demand falls. Hyperinflation is when inflation exceeds 50% per month. It usually happens when government prints money to cover deficits. To stop money creation, the fix is simple in theory, but difficult in practice due to the need for strong fiscal discipline. In Chapter 7, we start with an open economy, S equals I plus NX, then S minus I equals NX. That means the net capital outflow equals the trade balance. Here, I'd like you to review this table closely to better understand the connection between international capital flows and the trade balance. In a small open economy with a fixed world interest rate R star and X equals S bar minus investment, a function of R star. Real exchange rate epsilon equals E times P over P star. Net exports depend negatively on epsilon. If epsilon rises, domestic goods become more expensive and NX falls. 4 experiments. Fiscal expansion at home, then S falls and epsilon appreciates, and finally NX falls. Fiscal expansion abroad, then R star rises, I falls, and epsilon depreciates, and finally NX rises. Investment increase, I exceeds S, and epsilon appreciates, and finally NX falls. Growth in the nominal exchange rate, percentage change in E equals percentage change in epsilon plus pi star minus pi. Purchasing power parity, PPP, that is E times P equals P star. This means the nominal exchange rate reflects the relative price levels of the home country and the foreign country. The main focus of Chapter 9 is the solo growth model. The production function is Y equals a function of K and L. In per worker terms, lowercase y equals a function of lowercase k, where lowercase y equals y over L and lowercase k equals k over L. National income identity in per worker terms, that is lowercase y equals lowercase c plus lowercase I, with lowercase c equals 1 minus lowercase s overall times lowercase y, and lowercase I equals lowercase s times lowercase y, so lowercase I equals lowercase s times a function of lowercase k. Capital accumulation equation, that is delta lowercase k equals lowercase I minus delta times lowercase k. that is also equal to lowercase s times a function of lowercase k minus delta times lowercase k. In a steady state, capital per worker does not change, so delta lowercase k equals 0. Then lowercase s times a function of lowercase k star equals delta times lowercase k star. Increasing the saving rate raises investment, which increases lowercase k and lowercase y until a new steady state is reached. The golden rule level of capital maximizes steady state consumption. Lowercase c star equals a function of lowercase k star minus delta times lowercase k star. This is maximized when MPK equals delta. If lowercase k star is greater than lowercase k star goal, reducing the saving rate increases lowercase c star over time, even though lowercase I and lowercase y fall. But if lowercase k star is less than lowercase k star goal, increasing the saving rate raises lowercase I and lowercase y, leading to higher lowercase c star in the long run. However, current consumption temporarily falls during the transition. Let's go through the sample practice questions together. Question number 1. We're given the money demand function, M over P equals K times Y. To find the inflation rate, we take the growth rate of both sides. Since K is constant, we get percentage change in M minus percentage change in P equals percentage change in Y. Solving for inflation, that is percentage change in P equals percentage change in M minus percentage change in Y. Now plug in the numbers, so we get percentage change in P equals 10% minus 3% equals 7%. So the average inflation rate is 7%. The correct answer is B, 7%. Question number 2. This one is about trade balance and net capital outflow. Exports are $5 billion and imports are $7 billion. So NX equals negative $2 billion. Since NX equals net capital outflow, so it is also negative. That means the economy has a trade deficit and negative net capital outflow. The correct answer is A, trade deficit and negative net capital outflow. Question number 3. Now we calculate the real exchange rate between Swiss goods and US goods. We use the formula epsilon equals E times P over P star. Here E equals 5, P equals 1, and P star equals 2. So epsilon equals 2.5. This means it takes 2.5 Swiss goods to buy 1 US good. The correct answer is B, 2.5. Question number 4. We're looking for the steady state capital labor ratio, lowercase k star, in the solar model. At steady state, delta lowercase k equals 0. Then lowercase I equals delta times lowercase k, where lowercase I equals lowercase s times lowercase y. Then lowercase s times lowercase y equals delta times lowercase k. Plug in lowercase y equals lowercase k, takes exponent 1/2, and solving for lowercase k, we get lowercase k star equals lowercase s over delta over all square. And after plug in the value of lowercase s and delta, we find lowercase k star equals 4. The correct answer is C, 4. Question number 5. This question is about the golden rule level of capital. At a steady state, consumption is lowercase c star equals a function of lowercase k star minus delta times lowercase k star. The golden rule level is where this vertical gap is the largest. Looking at the graph, that is segment AB. So the correct answer is B, AB. Question number 6. We need to find the nominal interest rate and the price level. The real interest rate R is 3%, and the expected inflation pi E is 1%. So the nominal interest rate I equals 4%. Now use the money demand equation and substitute Y and I, then M over P equals 200. We are told M equals 100, so 100 over P equals 200, then P equals 0.5. Therefore, the nominal interest rate is 4% and the price level is 0.5. Question number 7. We are told that national saving is 300 and investment is I equals 400 minus 20R. A. In a closed economy, saving equals investment, so 300 equals 400 minus 20R, then R equals 5%. B. In an open economy with R star equals 10%, then I equals 200. C. Net capital outflow equals NX, then it equals to S minus I equals 300 minus 200 equals 100. So the country runs a current account surplus of 100. Question number 8. We are given S equals 300, I equals 400 minus 20R, and R equals 10%. A. The investment remains unchanged since R is fixed. Substituting the values gives I equals 200. B. Initial trade balance and X equals S minus I equals 300 minus 200 equals 100. After G increases by 100, S becomes 200. So new trade balance and X equals S minus I equals 200 minus 200 equals 0. So it drops by 100. C. Since net capital outflow equals NX, it also drops from 100 to 0. D. Lower net capital outflow means less supply of domestic currency, which causes the real exchange rate to appreciate. Question number 9. We are given that the per worker production function lowercase y equals lowercase k takes the exponent 1/2, and the depreciation rate delta equals 10% or 0.1. After solving the steady state condition, we find A. With the saving rate is 0.4, then capital per worker lowercase k equals 16. Output per worker lowercase y equals the square root of 16 equals 4, and consumption per worker lowercase c equals 2.4. B. With the saving rate is 0.8, then capital per worker lowercase k equals 64. Output per worker lowercase y equals the square root of 64 equals 8, and consumption per worker lowercase c equals 1.6. C. Saving more increase output but reduce consumption. That means too much saving can lower long-run consumption and overall welfare. Question number 10. We're given the production function y equals k take the exponent 1/2 times L take the exponent 1/2, and the depreciation rate delta equals 10% or 0.1. A. Divide by L, we get output per worker lowercase y equals lowercase k take the exponent 1/2. B. To find the golden rule level, maximize consumption per worker lowercase c equals a function of lowercase k minus delta times lowercase k equals lowercase k take the exponent 1/2 minus 0.1 times lowercase k. After taking the derivative with respect to lowercase k and set it to 0 and solving for lowercase k gives lowercase k star goal equals 25. C. Output per worker lowercase y equals the square root of 25 equals 5, and consumption per worker lowercase c equals 2.5.